I will give you several examples of cations and anions that are common. Sodium, also with the first group in the periodic table. We will take a look at it later. They're normally plus like that, yeah. Also K plus. And then we have magnesium 2 plus along with Ca 2 plus, Ba 2 plus, etc. And then we have transition metals like Fe. Now, transition metals can have multiple cations, like Ni, nickel, 4 plus. Yeah, so this is the special aspect to the transition metals. They can have different charges. Now, another common examples is NH4 plus. We call this ammonium. Yeah, ammonium, and so on. You can also try to find the examples for yourself on your own. Yeah, and also for anions, we have the -1 group, which is Cl minus, F minus, and Br minus from the halogen. Yeah, halogen groups that we will take a look at when we talk about the periodic table segments. And also, it is also common to have the oxide ions. Yeah, oxide meaning that you have oxygen in the systems. And for instance, we have CO3 2 minus, which is we call the carbonate. Yeah, carbonate. We have SO4 2 minus, which is sulfate. And NO3, this is minus, and this is nitrate. Okay, and we have ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. This is hypochlorite, chlorate, and perchlorate. Now, examples like this and so on. Yeah, of course you can have. Also, maybe I can write another one. Oops, sorry. I was trying to write this one. PO4 3 minus. This is phosphate. Of course, there are many more examples. Now it is your turn to get yourself familiarized with examples of cations and anions. And of course, what you also need to remember is the charge, yeah? Like 2 plus, 2 minus, and so on. Now, when you pair a cation and anion, they have to make up a neutral compound, okay? So when you pair, let's try pairing, where do I write? Here, yeah? Na plus with PO4 3 minus. How do we pair this? It has to be a neutral compound at the end. So in this case, because here you have +1 and here you have -3, so of course it has to be Na3PO4. Okay, so this is the compound that we called sodium phosphate. Okay, now another example. I will write another anions, which is Cn minus. This is cyanide. Now, what if I want to pair Ca2 plus with cyanide? Of course, you would want it to be a neutral compound, so this will result in, let me use red here, CaCN2. Yeah, so you have one Ca and you have two Cn because Cn is -1 and Ca is 2 plus. So again, you obtain a neutral compound because the number of electrons released by Ca, which is 2, should be the same with the number of receiving, in this case, anions, cyanide. So the cyanide has to be 2 as well. And this one we call the calcium cyanide. Yeah, you don't have to specify the number, so you don't have to say like trisodium phosphate. It doesn't work like that in naming the ionic compounds. Yeah, you don't have to say the number. When you say sodium phosphate, then people will automatically know that this one is the one you are referring to. Also for calcium cyanide, you can also just write it down as CaCN2 like this, and the name is also not calcium dicyanide, it's just calcium cyanide. So you don't put the prefix or suffix for number in this case. Yeah. Now what about the transition metals? So for transition metals, you have several oxidation number. Yeah, you have several cations. You can have Fe2 plus and Fe3 plus, and from here you can have FeCl2. Yeah, just take an easy example, and FeCl3. Now you can say that this is iron chloride, right? Before you can just say let me go back. You can just say calcium cyanide because calcium for sure is 2 plus and cyanide is for sure is -1. However, for this case, let me put the O here. Now, in this case, iron chloride could be iron 2 or iron 3. Yeah, it could be this one or this one. Therefore, in the case of transition metals, very often you would have to write down the what we call oxidation number. Yeah, which is basically 2 plus or 3 plus. If it's 2 plus, then you write it down as iron 2. Okay, let me put a line here. This one is iron 2 chloride, and this one is iron 3 chloride. Okay. Let's take different examples. Now we have a different pair. For instance, we have Ni 2 plus and Ni 4 plus. Yeah, and you want to pair this with the so this is obviously a cation. Let's pick an anion. You want to pair this plus, yeah, CHCOO minus. Yeah, now you can see that this is a more complicated anion. This one we called the acetate. You can have, of course, again, Ni. If it's 2 plus, then it will become CH3COO2. Okay, and you can also have NiCH3COO4. Correct? Check this out, yeah? If I made a mistake, just put your comments down below so then I can put a revision. But should be okay. So in this case, you have, what's the name? Let's name them. Nickel 2 acetate, and here you have nickel 4 acetate. Normally you put the number over here and then you write it down in the symbols. Yeah, 2 and 4 is like IV. I'm sure you know this. Okay, now it's your turn to play around. Try to pair as many different cations and different anions and try to name them. Don't forget, in the case where you have it common like this, sodium is always plus, calcium is always 2 plus, then you don't have to put the number. However, specifically for transition metals, you would often have to put which oxidation number that you are referring to. Your turn.